Hello students, hope you are doing well. In this video, we'll look into the next topics of gravitation. And the topics that we are going to look into are gravitational field. We'll try to understand what is gravitational field and gravitational field at a height h. And we'll try to find an expression for gravitational field at a height h from the surface of Earth. And similarly, we'll try to find gravitational field at a point inside Earth. Let's see, and we'll see how a gravitational field varies from one point to other point, both inside Earth as well as above the surface of Earth. So first, let's try to define gravitational field and gravitational field intensity. Gravitational field is the space around a mass where its effect can be felt by another mass. Not only gravitational field, any field. For example, let's say we talk about our acoustic field or the sound field. That means if I'm talking, if you are in a region of my sound field, you can hear what I'm speaking. And if you are out of the region of my sound field or acoustic field, you cannot hear what I'm speaking. Right? So similarly, if I bring another mass near, let's say Earth's surface or any other mass, if that mass can experience the gravitational force due to the first mass, then it is inside the gravitational field of first mass. Otherwise, it is outside the gravitational field of first mass. So that is why we define gravitational field to be the space around a mass where its effect can be felt by another mass. Now that's how we have defined field. But then if I say space around a mass, it's a vague quantity because we cannot quantify it, we cannot measure it. So we define one more quantity which is more measurable, and we call that as gravitational field intensity. Now gravitational field intensity at a point is force acting on a unit mass placed at that particular point. So for example, if I want to find gravitational field intensity at this point P, let's say this is the region around this mass, blue mass, where its gravitation effect can be felt. This is the field of this mass. So if this is at a distance r from this, I'll call this mass m1 and this as capital N. We are finding the field due to capital N. Then I can say force between both of them is m1 by r square. Now gravitational field at that point is given by F by m, because I'm taking this mass to be, m1 to be unit mass. So that will be equal to gm1 by r square by m1. I'll cancel this. I'll be left with gm by r square. Got it? So this is totally giving us the effect of this mass. So gravitational field at any point will give me the effect of a single mass. But when I'm talking about force, we need at least two masses. Now, is it a vector quantity or a scalar quantity? Now, because we have divided a vector quantity by a scalar unit, so it becomes a vector quantity. Now, if it is a vector quantity, what is the direction? So, if it is the direction of force acting on the mass m1. So, what is the direction of force acting on mass m1? Because gravitational force is attractive in nature, the force would be towards the center or towards the other mass. So this would be the direction. So how do I define the direction of force, gravitational field? The direction of gravitational field is along the force experienced by the unit mass. Or if I don't want to take unit mass as reference, I can say gravitational field due to mass is directed towards the mass. So if I want to generalize it, gravitational field due to a mass at a distance is directed towards the mass. So the magnitude is given by gm by r square and the direction is towards the mass. So this is what is gravitational field intensity. In some books, gravitational field refers to gravitational field intensity. Now what will be SI units of gravitational field intensity? This is force by mass. Force is Newton, so it will be Newton per kilogram. So SI units of EG would be Newton per kilogram. That is about gravitational field and gravitational field intensity. Now let's find out what is gravitational field at a point inside the surface of Earth. Let's say I want to find gravitational field at a distance r from the or distance x inside the surface of Earth. So this would be the portion which would be enclosed by this. So only this mass will create a gravitational field here. Or if I take a mass m1 for reference, I'll take this mass as m capital M. then the force would be equal to gmm1 by x square, right? So gravity, instead of I'm taking capital M to be the mass of the, you know, the region which is enclosed by the dots. Now what is M? M would be total mass of Earth by total volume. If I take the radius of Earth to be RE into volume of the part considered. So I can get rid of 4 by 3 pi and 4 by 3 pi. I'll get M equal to ME into x cube by RE cube. If I substitute here, the force would be given by GME, that is mass of Earth, into x cube by RE cube by x square. So that would, of course, there is a mass m1 also. The force would be equal to GME m1 into x by RE. Now, if I want to find gravitational field intensity, it will be dividing by m, so that will be GME into x by RE cube. So I can see that gravitational field intensity is directly proportional to x when x is less than r, or that the point is inside the Earth's surface. Now let's try to find out gravitational field intensity at a point outside the Earth's surface. Let's say this is the point, at a distance x from the surface where I want to find gravitational field intensity. Now, what is gravitational field intensity? I want to find force. I keep a mass m1 here. This mass is, let's say, me. Then force would be equal to gme m1 by x square. So force is gme1 by x square. So gravitational field intensity would be F by m1. That will be equal to gme by x square. So what do I get? I get gravitational field intensity to be inversely proportional to square of the distance. Now one more thing that you can notice, gravitational field intensity has the same expression as that of acceleration due to gravity. So in magnitude as well as in direction, so gravitational field intensity is equal to acceleration due to gravity. Now if I draw a graph between gravitational field intensity and the distance from the, let's say, the center, I'll say this is x, this is gravitational field intensity. From the center to the surface, it increases linearly, and after that it decreases as 1 by r square. This is how the graph changes. This is gravitational field intensity and this is distance. So what all things we have seen? We have defined what is gravitational field. Gravitational field is the space around a mass where its effect can be felt by another mass. Of course, it can be generalized for any mass. Here we are talking about only Earth. Now it's a vector quantity, so it is directed towards the mass which is causing the field. And the next thing that we have seen is how does gravitational field vary for Earth or for any other planet. Inside, we have seen that gravitational field is directly proportional to the distance from the center, and outside, gravitational field is inversely proportional to square of the distance from the center. Now whatever gravitational field expressions that we have derived are valid for any solid sphere. It need not be only Earth, it can be any solid sphere for which the gravitational field intensity expressions that we have derived are valid. So that is what is there in gravitational field and gravitational field intensity. Hope you could follow it, and I hope you are watching other concept videos as well as videos on questions which are graded as level 1, level 2, level 3 for various competitive exams, and you're making use of that. Thank you very much for watching this video, and keep watching the other videos of concepts as well as questions and solution. Thank you very much.